Alrighty, go. Some other music. All right. All right. Hello, 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 hello. Hello. Where's my chat box all the way over? There we go. Sure. All right, there we go. I'll wait for 10 minutes or so. All right. Hello, hello, hello. All right. I passed the vibe check. Thanks, Neon. Gotta have a little vibe in here. How you doing today, man? All right, that's good. Any plans for the weekend there, buddy? Probably see Christmas lights somewhere. Fair enough. It's gonna be it's about Christmas light season, so right after Thanksgiving should be put up here without any trouble. So shorter compared to what? Short then? Okay. I was like, wait, shorter compared to what? I don't even know what you're talking about. Yeah, all right. All right, about 10 minutes in here, hopefully. May just be you and I here today, but that's okay. It'll be pretty short then, if you want it that way, so. Shorter than myself. I don't, I don't know how tall you are. I've never seen you in person, Neon. I have no idea, man. I mean, I'm like 5'10", but I don't know if you're taller or shorter than that. So 5'5.5". All right, 5.5. All right, that's fair. Honesty, I didn't even grow until I was in college myself. So I mean, my body's like, my thyroid was like, yeah, we'll just wait until later. I'm like, okay, that's fine. Okay. All right, we're going to do a short lesson here today. Just you and I, but won't require much participation. We'll have Fernando here as well, so there you go. Short lesson here today. Okay. Okay. So, I mean, I don't know. Whatever you want, Neon. All right. Uh, okay. Let's go ahead and get started here. Okay, let's get started today. Welcome back to Wednesday, end of the week time today. So today we're moving on forward here in chapter 12. We're going to finish up here with section 12.5. Section 12.5 is not a super long section here. Won't take us too much time to do. So I don't expect us to be here too long for today. We only have this section and the next section, and then we are effectively done with the textbook, Dunzo. And then that's it. That's all the new material. But we'll have some things to discuss here next week, nonetheless, regarding the test here. Remember that there is no final exam for this course. Okay, so you don't have to do. There's no final exam whatsoever for the course. So everything is about the tests and the homework there. So be sure to finish up that. But I'll describe more here next week, so that way some deadlines are set. Okay. So today we are going to use one of the things that we talked about here last time. Last time we talked about the idea of z-scores. Okay, so let's talk about z-scores here in particular. All right, and there you can see up above, you can see the z-score for again, the formula here for a z-score. So if we go back here to um, oh, all right, so specifically here, we want to talk about z-scores here. All right, that's the goal here. Oh, that's pretty bad. Hang on a sec. Is this bad? All right, let's try that again, shall we? All right. So let's talk about z-scores here first. We had found out how to find the standard deviation, and to do that, of course, we took the data item minus the mean and all that stuff. And a z-score was another way to kind of just, see how many standard deviations a data item was away from the mean. Again, what is the z-score definition in terms of its formula? Again, that was taking the data item, whatever that data item is, minus the mean of that in that distribution. all right, divided by the standard deviation. We looked at some predictable patterns here last time with the normal distribution. Now today we want to go ahead and interpret some of those patterns within the normal distribution here. This is more in the form of our friend, what's called percentile. So let's say we want to take a data item and we want to make a proper conclusion out of it. Maybe we want to see the percentile about where that would lie within the distribution itself. So let's at least get a good idea about what percentile is. Now, the best way to kind of describe percentile here specifically is to talk about, basically think about like a placement test, like an ACT or SAT test. Now, if you take like the ACT, they'll give you like a score report after you take the test and everything. So you do this thing, you get the score report back. It tells you how many points you got, but also along with that, it tells you what percentile that you ranked in. Meaning to say, if you scored in the 95th percentile, it would mean that you did better than 95% of everybody else who took that same test in that particular subject. Okay, that's essentially what's happening here as well when it comes to percentile and how we look at it here in statistics. Okay, so this is basically, this is the percent, I want to say it this way. Go ahead and put this out in text. All right. This is the percentage of which data item. No, you know, I better probably want to say this a little better. I just want to say this correctly here. So the percentage of which the data item is larger than other data items in the distribution. Okay. So if you're, like I said, if you're in the 95th percentile, you're in really good shape, all right? It means you're scored really high in comparison to your peers. Okay, now what we want to do is we're going to associate the z-score that we have here, and we want to associate that with the percentile that we see here, and we'll see exactly how to put 2 and 2 together. Okay, now first and foremost here, there's going to be an important key here, and the key here for this one is going to be in the textbook. Okay, and let me go ahead and reference this page here. You're going to use page, specifically, page 822. Use page 822 for the chart. Now, we're looking at the basics here, so if you want to do later statistics, then you can find even more accurate percentages. But in any case, so you're going to use this for their z-scores and percentiles and respective. You know what? I don't know why I'm even writing this out like this. Okay, let's try this again. Why am I doing things that are harder for me? All right. All right. Use page 822 and use the table with the z-scores and their respective percentiles. All right. So that's, if we go back here for just a second, what's this table that I'm referring to here? Well, the table looks like this. This is the table that we're going to be using here with its respective z-scores and the percentile that is associated with each one. Notice that some of them go to 2 decimal places, some of them go to 1 decimal place. Just depends. We're just going to kind of round a little bit if we need to, depending on what information that is available on the chart here. Okay. Again, if we were doing hard statistics, like, hey, let's do more hardcore statistics, hey, then yeah, of course the z-score here will be much more refined. But we don't need to worry too much about this one. So, okay. In any case, let's go ahead and take a look at some examples here, and let's see how we can factor in percentiles here using this table that we see here on the screen. Okay. So, okay, so Gonna go with a problem here. Okay. Alrighty. All right, so this is on page 826. Oh, you know what would be helpful? That if I switch off from my main screen. There you go. Sorry about that. You guys gotta tell me I'm a dumbass. There we go. I forgot I gotta switch off to my main screen there and put it on here. Of course. All right, my bad on that. You can go ahead and copy that down if you feel like it. By the way, the table that we're looking at here is we're using this table that you see here. This is in your eText, by the way. So you can reference this here with your eText. And again, this is the keys that we have here. Again, the z-score here is the data item minus the mean divided by the standard deviation. Percentile being the percentage which the data item is larger than other data items of the distribution. And the key here, we're going to use this table here to find the respective percentiles and the z-scores. Now, in this case here, let's look at page 826, pardon me, is let's say we have a z-score here. Let's say that z-score here is 1.2. Let's find the percentage that is above and below this z-score of 8.2. Okay, so that's what we're going to do here in this case. I'm going to find percentage above and below the z-score. Good. All right. Now, these are two separate parts here. Okay, so let's go ahead and talk about the first one here, which is above. Okay, if we talk about above, all we want to look here is at the z-score itself. So the z-score here is 1.2. Now, let's shrink this down here for just a moment. Okay, so let's look at the table here in this case. All right, so the table says specifically that at the z-score here of 1.2, the percentile here is 88.49%. Okay. So if we look above here, the percentile is 88.49%. Okay. So it's the 88.49% percentile here in this particular instance. So how many of the data items are above the z-score given? Well, all you have to do is, since everything is 100%, we're going to take 100 minus 88.49. And so this is going to equal 11.51%. So how many data items are above the z-score of 1.2? Well, 11.51% of data items are above the z-score of 1.2. How about below? What's the percentage of data items below the z-score of 1.2? Well, that's actually the percentage that you see right there, the 88.49% straight up. So if you're looking at the difference here between the two, it's really not too hard to see here in this case. All right. So the only, again, the only difference you have to take here is that above requires you to do 100 minus that percentile. Okay, let's go ahead and take a look here at another one. How about this one here? All right. So the next one I'm going to do here specifically is going to be, how about between, let's look at two values here. Let's look at between a z-score here of minus 0.40. And I don't know, 0.85. Okay, so here we got two z-scores. We want to find out the percentage of data items that lie between the z-score of minus 0.40 and a z-score of 0.85. Now, all we have to do is look at the table here, and we see here at minus 0.40, we get the percentile here of 34.46%. And at 0.5 here, 0.85, pardon me, we get the percentile here of 80.23. Therefore, if we want to find somewhere between these two values, we're just going to go ahead and subtract these two from each other here. So we're going to take 80.23 minus 34.46. And so if we subtract that from each other, we get 45.77 as our final answer. Okay, so 45.77% of data items are between the z-scores of minus 0.4 and 0.85. All right. Are there any questions about that so far? Any questions so far? Here we go. Questions about Neon or Fernando? I'm going to take that as a no. All right, I'm going to move. Okay. Okay, cool. All right. All right. Can't answer, just have your headphones. Okay, fair enough, man. Fair enough. That's cool. Hard to type. Okay, that's okay. We're just going to go through this pretty fast, so no worries. I'm not going to ask you guys to really answer too much here today, so just want to. I always ask if you have any questions just in case, though, if I go too fast. All right. All right, next, let's go over the next question here. Next question is, again, on the same page. So we're given, let's say we're given, this is going to be number, let's go with, yeah, let's go with the number 18 here. That's the next example I want to do. Okay, so basically, we're given a normal distribution here with a mean of 121 and a standard deviation of 15. So let's at least write that down. The mean is 121 and the standard deviation is 15. Okay, what is asked us to find here in this case is find the percentage of data items that are the following. Okay, so the number 18 asks what's the percentage of data items that are going to be, oops, sorry, not above, I meant below. Below 148. Now, in this case here, we're going to go ahead and use the z-score formula here that we have up above at the very top here. I know it's written fairly small, but in this case here, we're going to need to use it in this instance, meaning to say we need to do this, find the z-score here of 148. So let's find that. We're going to plug in 148, the data item, minus the mean. divided by the standard deviation. And so if we do this out here, that's going to be 27. So let's figure out what this is. Divided by 15. So what we get here is we get a z-score here of 1.8. All right, that's what we got here going on so far. Now, with the z-score of 1.8, we want to figure out the percentile that's associated with the z-score 1.8. Well, according to our chart here, that percentile here is 96.41%, and that will represent below 148. So that's going to be our final answer for this problem, 96.41%. Let's try another one, though. Just a couple more here. And honestly, yeah, there's not much to it, so. All right, so the next example here is, again, keeping the same standard of mean with 121 and standard deviation of 15. Let's say I want to find above, and then this one's going to be, I'm going to do that one. So above, let's see which one, above 130. This is the next one over, number 19. So again, let's find the z-score here for 130. I'm going to set that equal to 130 minus 121, which is the mean, divided by the standard deviation, which is 15. So we're going to go ahead and do this one out. So here we get a z-score here of 0.6. Okay. All right. So we take a look here at the z-score of 0.6 on our chart. And as you see there, that's 72.57. However, 72.57 being the percentile, remember, only represents below, not above. So because it's above 130, we want to go ahead and take that 100 and subtract it by the 72.57. And what we're going to end up with is we're going to end up with 27.43%. Okay, so 27.43% would be your final answer for that. All right, and let's look at one more example here. All right, let's say we're trying to find out between two values, about between what number is this? 26? Okay. Between 109 and 133. So let's say we're trying to find the percentile here, the percents here between 109 and 133. Okay. So let's take a gander here in this case. Again, let's find the z-score for both of them, and then we'll find their respective percentiles. So the z-score for 109 is 109 minus 121 divided by 15. And so let's do that one first. It'll be negative, but that's fine. We don't care if it's negative. All right, so here we get negative 0.8. All right. And then here, we'll get to the percentile here in a second, but let's find the z-scores here first. So 133 here will be 133 minus 121 over 15. So if we take a good look at this one here, this one, let's do this on the calculator here. Again. So we're going to get 0.8 here in this case. So we get negative 0.8 and positive 0.8. All right, seems fair. Okay, so the next part here is basically finding out the respective percentiles using the chart here that we see on the left. All right, so let's look at minus 0.8 here first. So minus 0.8 here has a percentile of 21.19. And positive 0.8 here has a percentile of 78.81. Since it has to be between these two values here, then what we're going to have is we're just going to take 78.81 and subtract it from 21.19. So here we're just going to end up with 57.62. Yeah, 62. That's right. Okay. So 57.62% of data items are between 109 and 133. All right. Okay. Any questions, gentlemen? Just type yes or no there. Nah. Okay. If there are no questions, that is the entirety of section 12.5. That's it. That's all of it. Right there. Took me 25, 30 minutes at best. That's it. That's it. So, yeah, that's the lesson. You got short, we got short. There you go. All right. So, hey, you asked for short, I gave you short. That's it. That's the section. We're going to do the last section of the textbook here next time on Monday. All right? So, not a whole lot that we did cover here today, but a little bit here that still holds relevance. All right? However, one thing that I do want to remind you of here, guys, is please for the next section, bring your calculator here, a graphing calculator here, or again, if you can find one online that you can use here, that's like a TI 80 something, then we're going to be using that here for next time. All right. Okay. Great job, you guys. I know that wasn't a whole lot here today, but there you go. Content is still achieved. All right. Sometimes it just works out that way. All right. In the meantime, though, gentlemen, I would like you to enjoy yourself as much as possible. All right. Please have a chance to sit back, relax, and enjoy, and then make sure you catch up with all the work here in the course. Okay. Again, most everything is posted here. I'm going to be working a little bit behind the scenes in terms of like tests and whatnot. So I'll be working on that here, and like I said, I'll talk more about that on Monday once I have everything more finalized and ready to go for you. Okay. Great work today, everybody. All right. And that'll take care of it. Thank you, guys. Love you both. All right. Have yourselves a very wonderful afternoon. Take care of yourselves, and we'll see you on Monday. All right, everybody.